I know sometimes that students might think that faculty are scary, but honestly, we love to talk about what we do. I mean, we do this job because we love our students and we love our research. So students should come up to us after class, come meet us in our office hours. We're happy to have them.
From the Curtis R. Priam Experimental Medium Performing Arts Center, MPACT, at the campus of Rensselaer Polytechnic Institute, I'm your host, Dr. John Wexler, Vice President for Enrollment Management, Rensselaer, and this is Crashing the Faculty Lounge. Our guest today is Dr. Karyn Rogers. Dr. Karyn Rogers joined the faculty at Rensselaer Polytechnic Institute in 2013 after serving as a research scientist at the Carnegie Institute of Washington. Prior to that, she was an assistant professor at the University of Missouri and a Deep Ocean Exploration Institute postdoctoral scholar at Woods Hole Oceanographic Institute. Dr. Rogers completed her PhD in Earth and Planetary Sciences at Washington University in St. Louis, where she also obtained a master's degree. In addition, Dr. Rogers has a master's degree from Stanford University and graduated Harvard University, where she received her undergraduate degree. Dr. Rogers is director of Rensselaer Astrobiology Research and Education Center and the Institute for Data Exploration Applications. Dr. Rogers' research focuses on the relationship between microbial communities and environmental conditions in extreme ecosystems and is broadly applied to understanding the nature of the origin of life on Earth, the potential for life throughout the solar system, and the extent of life in modern extreme environments. Dr. Rogers' research program includes fields research in early Earth and Mars analog environments, as well as laboratory experimental studies of the origin of life, microbial behavior under extreme conditions. Dr. Rogers, welcome, and thank you for letting me crash the faculty lounge.
Thank you so much. I'm really excited to be here.
Great, Karyn. Our first question that I have is, can you discuss some of the leading research you're working on and what outside agencies or organizations are you involved in your research?
I'd be happy to. This is what I do all day long. And so I'm really always excited to talk about my research. So when I came here in 2013, I was actually working on microbes that lived at the bottom of the ocean. I was really excited to try and understand why they live in these crazy places, like in hydrothermal vents. Yeah. And I started working on sort of why they live under high pressure. Because if you and I went to the bottom of the ocean, we would get squished by the pressure, and they're quite happy about it. And so I had been working on that for a while. I started building some high pressure experimental and sampling equipment. And when I got here to RPI, having studied microbes that live in weird places and microbes that really look like they are relatively primitive on the Earth, I kind of got sucked into another project that has been longstanding at RPI, which is the search for life's origins on Earth. So I started doing that. We have a long history at RPI of studying the origin of life on Earth. And fast forward 10 years later, that's what we do most of in my lab now. So by 2019, we established the Rensselaer Astrobiology Research and Education Center, our RARE Center. This is a follow-on from the New York Center for Astrobiology, which has been here for quite some time. Our work now is funded by a pretty large center grant from the NASA Astrobiology program. I am also part of the NASA Astrobiology program, where I'm co-lead of the Prebiotic Chemistry and Early Earth Environments Consortium. So here at RPI, as part of the center, one of the things we're doing is we're just now completing the construction of the Early Earth Laboratory. Wow. What we do there is we construct a bunch of different kinds of devices. And so these are high pressure, high temperature devices that allow us to combine rocks and minerals and water and gases and organic compounds. And we try and see what kind of chemistry can happen in environments that we're trying to make sort of look like early Earth environments. And that's going to hopefully tell us the sort of sequence of chemistry that led to the origin of life on Earth. So that's mostly what we're doing right now in the EEL lab.
Cool. Talk about the NASA grant that you received, what was involved in that, and what does that allow you and the university to be able to do?
Yeah, this is something that we're really, really excited about. RPI has been involved in the NASA Astrobiology program with their center grants for quite some time. And this is our third large grant from NASA to do this work. And we were selected in 2019 as a 5-year center-sized institution. And so what that means is we had, at the time, 6 faculty members here from RPI, and we have 8 collaborating institutions across the country. And so all of us together work on trying to understand a few things. We have sort of this big overarching question, which is, what was the early Earth like and how did that give rise to life? And so on this team, we have geologists, we have geochemists, we have organic chemists, we have analytical chemists, and we have some biologists. And we work across all the teams across the country to try and answer this question. Now, what that means for us at RPI is that we have sort of a very dedicated and focused group of both graduate students and undergraduate students, as well as faculty members, who are all trying to understand this big question of how life started. And so we've expanded our graduate program. It currently hosts students in biology, chemistry, earth and environmental sciences. We've also had some engineering students join us. And we also have undergraduate students who spend a lot of time in our research labs across all of the faculty in the Rare Center doing all kinds of interesting research. In fact, we have 2 undergraduates giving posters at the Undergraduate Research Symposium. Wow. Yeah, just really, really soon, in fact.
Yeah. Karyn, you had brought up in regards to our grant with NASA that there are 8 universities involved. Are we the lead in that?
We are the lead. We are the lead of that project. We've sort of been the center of astrobiology at RPI, and we've brought together an amazing team from around the country. And we work with our partners, our other 8 partners around the country, regularly, right? And so we share students, we share ideas, we share publications. And one of the things that is possible is undergraduates in the minor, hopefully in the minor, but really undergraduates in any of our labs, have access to those folks and to their labs and could maybe do an Arch Away experience in one of those labs. And so there's lots of opportunities that come with this sort of grant.
And that would be kind of cool because they do it during their junior year, and then they could come back to the senior and be able to see how that research at another institute relates to the research and connects to what they're doing on campus.
Yeah, that's right. And to have that perspective of having a different university, first of all, that's just invaluable for any student,
Sure.
right? Is to get a variety of experiences, to sort of see how other labs and other disciplines run, but also to sort of build that progression of research, right?
Yeah.
By doing something here, going and adding something new that maybe we don't have the ability to do here, and then taking that new knowledge and bringing it back. That's how science works, and to give our undergraduates that experience really early is really very exciting.
And that's kind of the premise of the Arch program, was to bring back what you're learning from the outside before you graduate.
That's
so
right.
that your classmates and your faculty can discuss and interact with you.
Yeah, that's right. And it's the beauty of the Arch program is because it makes RPI bigger than it is without having to get bigger than it is.
Right.
It's really nice that way.
That's great. So talk about how an undergrad would get involved in research in your area, how one goes about that, and then what, like you're talking about these 2 students who have their posters, which is a big deal.
It's a great idea.
Of how one starts from maybe coming in as a freshman all the way through when they're planning to graduate, how one would progress in doing research or looking into that.
Yeah, that's a great question. And one of the things we do in Rare is we really do like it when students come to us early, right? I mean, it's astrobiology, so lots of students are interested in sort of taking our classes and seeing what this is all about. We have a minor in astrobiology, and we can talk about that later.
Yep.
But when students come in, they tend to they sort of do things like crash the faculty lounge, but they crash my faculty office instead.
And that's encouraged.
Absolutely. My door is always open, and I love seeing students come and talk to me and ask me about the origins of life and astrobiology and going to the bottom of the ocean. I mean, this is why I'm here.
Right.
So what I've done in the past, and what a lot of my Rare faculty colleagues do, is we like to get our undergrads started early doing research in our lab, right? And so we usually pair them up with a graduate student and with one of us. We develop small projects, when our undergraduates are maybe freshmen or something. And then we slowly teach them things. And, I've had undergraduates sort of be authors on papers. They've led their own projects by the time they're done, because once you stay for 3 or 4 years in my lab or any lab, you really get to learn a lot, and you get to be pretty independent. And so this is, we start early, and then we try and keep them in astrobiology the whole time they're here.
So I think it's a good lesson for some of our students that are incoming this year. Rensselaer is a Research One institution, one of only 37 private research institutions in the U.S. And if you're taking a class and you really like the faculty member, go talk to them and find out, or someone like yourself or in any discipline, what they're involved in and how they can get involved if that's something from that standpoint.
Yeah, absolutely. I mean, I know sometimes that students might think that faculty are scary, but honestly, we love to talk about what we do. I mean, we do this job because we love our students and we love our research. We just get excited about it. We would do it for a hobby. So, don't tell them that.
Exactly.
But we really would.
Yeah.
So students should come up to us after class, come meet us in our office hours, come talk to our graduate students, get tours of our labs, and see what they like and see what they're interested in. We're happy to have them.
That's great. As you can hear, there are a lot of great things taking place at Rensselaer. Rensselaer is located in Troy, New York, and our admissions office is open 6 days a week for visits. We'd love to have you come and visit and experience all this for yourself. To do so, you can go to go.rpi.edu/visit. To register to come to campus for a visit, go.rpi.edu/visit. You had brought up the minor in astrobiology. Talk about that a little and what type of student might be interested in adding that on to their major.
Yeah, the nice thing about the minor in astrobiology is we've done a lot of work on it since NASA gave us our grant. We sort of reinvigorated the minor and we added some new classes. We changed the curriculum. And so the minor now is really good. I mean, really great for anybody, for any undergraduate at RPI. We have a lot of our minors in the School of Science and in the School of Engineering. And so it's not really a credit-heavy minor, right? You take our Intro to Astrobiology course, you take our Origins of Life seminar course. You actually take that twice. It's kind of a fun course because we sit around with all of the faculty and the graduate students, and we think about great new research questions to ask. And then you take related courses to astrobiology that are most pertinent to your field.
Right.
And so if you're a biologist, you might take things like geomicrobiology or geobiology, but we also have engineers who are astrobiology minors, and the courses they take are probably more related to engineering new systems that we might be able to build in the lab. And so you can really design the minor any way you want that best suits your interests. And that's kind of the fun thing, not just about the minor, but also about astrobiology in general, because you can be a geologist or a biologist or a chemist or an engineer, and all of us are astrobiologists because of what we're studying.
So, Karyn, the minor in astrobiology comes along with a research requirement. Talk about that and the interaction they end up having with specific faculty.
Yeah, that's one of the highlights of the minor is that every single student coming through has a research experience with one of the astrobiology faculty. And that gives them a real sort of one-on-one connection, not just with a faculty member, but also with something really specific that's going on in the laboratory. Most of our undergraduate students will work at least with one professor and sometimes with many of us. Right. They're often working side by side with another graduate student, which is how a lot of our undergraduates end up as authors on posters or as authors on publications.
Nice.
And the nice thing about the research and why we have this requirement is because astrobiology is not just this stale discipline. It's active and it's interdisciplinary, right? And so you really have to bring expertise from several different science and engineering disciplines together. And the best way to do that is around a specific research project, right? And so that's largely what we do. In addition to the actual research requirement, we also have a capstone requirement. And that capstone requirement is a presentation of their research outcomes. And so there's a lot of ownership and sort of pride that our students get in completing a project and then presenting it. So they might present it at the undergraduate research symposium, but we have also sent our undergraduates to local, regional, and national conferences to present their results. So it's a really great opportunity to do real research and present it to the scientific community.
That's awesome. And I also suspect that positions them really well if they're deciding to go to graduate school or going into the workforce, or maybe want to go to graduate school down the road, that they can show an institute the type of research they've done at an undergrad level, which is incredibly impressive.
It really is. And speaking from the perspective of somebody who hires graduate students and
Sure.
reads through graduate applications, that is always at the top of my list, is has there been an independent research project during their undergrad career? And not every undergrad across the country really has that opportunity.
Correct.
We do that a lot here at RPI, and it's something that really, really drew me to the place when I got here 11 years ago. But it's a really special thing. And so if you're going off to graduate school, or if you're thinking about graduate school, getting that undergraduate research experience is really invaluable. But even if you're not going to go to graduate school, having the experience of doing something independently, doing something that you own, and seeing it through to the end and presenting it, that shows a level of completion and a level of responsibility beyond just coursework. And that's something that I think RPI is really good at sort of giving our students an opportunity to have.
And it's the benefit, we're 85% undergrad.
Yep.
So the opportunity is there where, as you said before, it might not be at another school that's larger in size and scope.
That's
for
right.
the undergrad to be able to get that type of opportunity.
Yeah, that's right. I think most of our undergrads end up in a research lab at some point in their careers here. And honestly, the faculty love to have undergrads in our lab. They're really just so good. They're so good. They're so smart.
That's great.
I'm glad I'm not an undergrad. I'm not sure I could keep up.
I'm sure you could. Thanks so much for tuning in. We'll see you back next time as we continue our conversation with Dr. Karyn Rogers. Until then, I'm John Wexler, and this is Crashing the Faculty Lounge.